Hello, everyone. Good morning, good afternoon, good evening. I am Jayashree Hegde, welcoming you all to this exciting webinar on achieving 200 million concurrent connections with the HiveMQ platform. Today, our experts from engineering team and product marketing team will share their insights on why scalability matters in IoT world, why HiveMQ tested 200 million concurrent connections, and how did we achieve this industry-leading feat. Stay tuned with us throughout the webinar as we will be demoing our benchmark results and handing out the benchmark report. Before we kick off this session, I would like to share that we are recording this webinar and we will share the presentation slides as well as the recording in a follow-up email. During the presentation, if you have any questions, feel free to add them to the Q&A box in the control panel. We will have them all covered up during the dedicated Q&A after the presentation and the demo. We will be running a short poll during the Q&A. I request you all to cast your votes. Now, without further ado, I will hand it over to Gaurav. Welcome, everyone. Over to you, Gaurav.
Awesome. Thank you, Jayashree. Hi, everybody. Welcome. Greatly appreciate you made time to join us today. My name is Gaurav Suman. I'm joining you from Ottawa, Canada. I lead product marketing here at HiveMQ. And with me here is Tamer Shahin from the product development team. Tamer, you want to say a quick hi to our audience and then I'll get going?
Hello. Hi, everybody.
Awesome. So in the next 20 or so minutes, the plan is to talk to you about the motivation and the rationale behind doing this 200 million benchmark. There's a purpose, there's an advantage, there's a benefit for you as a client, perhaps, on looking at this degree of scale. We have saved plenty of time towards the end for answering any questions you will have. But don't wait for the end. Keep posting your questions in the Q&A area. Jayashree and I will keep an eye on the questions. And then once we finish the demo, we will be very happy to answer your questions. Please also note that portions of this webinar are pre-recorded only because we had to accommodate for the build-up time and the ramp-up time for the test. So with that said, I want to start by putting some numbers in context. So think about it, right? Big picture, there's like 8+ billion people on the planet today. And 15%, that's what data tells us, of those individuals are living in homes with at least one smart device, or, for people like me, one too many smart devices, right? And that's rapidly growing. You see the data, it's showing 14.2% year-on-year change in the penetration of smart home devices worldwide. And that's obviously an average. Economies like US, UK, Germany will have higher penetration, 50+% in most cases, and emerging economies might be lower. So just wanted to acknowledge that fact. But these are big numbers. And these connected devices, in some cases, they are helping people stay healthy, stay safe. And the revenue potential that it creates. I mean, imagine the $60+ being spent on an average, again, on fitness and well-being per user on the back of this connected ecosystem. The potential for revenue and spend here is phenomenal, right? And all of this is true as of today, while we still have a third of the world's population offline. They haven't yet tasted, experienced the value of internet, and then again, living in a connected world. So that's the potential and opportunity which is coming up. Now, if we move our focus away from strictly consumer technology and look at some data from the industrial perspective, we are trending towards 27 billion connected devices by the end of 2025. So this is data from IoT Analytics from last year. And the growth rate here is accommodating for the little blip that we saw because of supply chain disruptions, chip shortages. So the CAGR slowed down a bit, but then picking right back up and leading us to 27 billion connected devices in less than 2 years from now. Now, this is impressive, but what if I told you that this is not mobile phones, this is not laptops, this is not tablets, this is not connected consumer technology, right? Check out this footnote here. They're saying that we are talking about, not consumer technology, not RFID tags, but gateways, IoT sensors which have a degree of smart built into them. That's the technology which is leading us to 27 plus billion connected devices by end of 2025. And of course, a part of this is on the back of the adoption of technology which is built for IoT purposes, right? 5G, for example, is expected to drive a serious degree of growth here, as you can see from this data point. So I hope that makes sense, right? Because there is, of course, the human side of things. So the internet for humans, and then we have the internet of machines here. And that's where, IoT, as you can see, is trending towards tens of billions already. Now, in the big picture, IoT is solving some of the world's most pressing and urgent problems. These challenges and their scale, I don't have to explain to you how big they are and how pervasive they are and how they don't apply to one particular geography or national boundary. And all of these businesses, companies, areas have the value from a connected perspective. Just to name a few interesting examples, HiveMQ is supporting customers in the case of, say, IAV automotive engineering, where the rain sensors on the windshield wipers, that data is crowdsourced, and they are able to predict flash floods in cities, right? So imagine the advantage it creates from a smart city perspective. We have Arkia on Life, another interesting use case where we are supporting at-home living, senior living, assisted living, and Arkia on Living is using our technology to help people live longer, live more healthier lives. And that's obviously the scale is the aging population of the world. Proximi is an interesting use case we have where remote robotic surgery is happening on the back of HiveMQ technology. But I'm just raising these examples just to share with you sort of the size spectrum and the scale of opportunity here for IoT. Now, why do customers care about this, right? They are trying to obviously continuously build new digital products, creating new customer experiences, and creating new efficiency in operations. So today is not the day to dive too deep into our customer use cases, but I do invite you to check out our website where we explain to you how connected cars, manufacturing, this whole spectrum of IoT use cases is something that we are very proud to serve, and we have customers and customer stories to share with you. So I invite you to check that out on our website. Now, before I move on to the demo, just want to make sure we are all able to see, MQTT for the de facto standard that it is, and perhaps most of you on the call know about this already. I think it's a good place to remind ourselves why MQTT is so special and has become the de facto for IoT messaging. So MQTT is the protocol which has been written considering and accommodating for the challenges and the hostile nature of IoT, right? These are devices which some people would not even touch for 5-10 years, right? The battery power, the compute power, everything is at a premium. We're talking about hundreds of thousands, and today we are talking about millions of devices. And they are distributed, they are geographically spread out in most cases, mostly in areas where connectivity is an issue, and MQTT factors in all of this. It's meant to be lightweight, it's meant to be efficient, it's smart enough to support bi-directional communication on the same channel, and can of course scale to the millions of connected devices that we already have in operation. But then now we're talking about, of course, a couple of 100 million devices and beyond. And it is also optimized for security. I mean, however challenging the infrastructure might be, but the security over the hostile environment in which it is supposed to operate, that's also something the specification accommodates and talks about quite clearly. Now, this choice and this preference of MQTT shows when you have a survey like this going out, the one you see on the right-hand side of your screen. So when IIoT World did this survey late last year, MQTT came out on top. So this is a survey done from from the perspective of getting the view of technologists across industries, across geographies, and we gave them a multiple choice response option. MQTT came out to be the preferred protocol for fulfilling their IIoT strategy. So right there, you can see that this is something which is already helping customers meet their IoT goals. And today we are talking about one such goal, which is of scale. So all that said, a quick mention that HiveMQ continues to actively promote the adoption of MQTT. So the fact that we are part of the Oasis Foundation supporting the Eclipse work, whatever evolution is happening on top of these standards and specifications, one example being Sparkplug, we are right there, speaking for the standards, speaking for our customers, making sure that we are continuing to grow and improve the standard and the adoption. HiveMQ is at the front lines of that. And now it's time for the much awaited demo. Bear with me for a second here and I'll get that going for you. Thanks again for Vladimir to have done this for us. Bear with me 1 second and we'll get that going. Thank you so much.
Hello, my name is Vladimir. I work at HiveMQ in the area of distributed systems. Today, I'd like to demonstrate how our distributed MQTT broker can handle 200 million concurrent connections. So let's first take a look at the objectives of this benchmark. First of all, we want to connect 200 million clients to a cluster of HiveMQ broker instances with 5 million connections per node. We also want to push 30 million messages per minute through the cluster, thus testing the real world like messaging and subscriber patterns. So let's look at the AWS console here. So here we have our deployed instances, 92 in total. We basically have 40 nodes cluster of HiveMQ instances. So each HiveMQ instance runs on M5 and 8x large machine. And these nodes are general purpose virtual machines, which offer 32 virtual CPUs, 128 gigabytes of memory, 300 gigabytes of GPU-free storage with 3,000 IOPS. In addition to the broker deployment, we have a HiveMQ Swarm deployment. HiveMQ Swarm is a load testing tool that is used both for internal load testing of the broker as well as for sizing on-premise offerings for our customers. Swarm uses 51 nodes, one of which is a commander, and the others are the workers that do the actual load generation. All Swarm instances run on R5 and 4x large memory optimized machines, which are a bit smaller in terms of CPU, but still they offer 8 virtual CPUs, 128 gigabytes of memory, 300 gigabytes of GPU-free storage, and 3,000 IOPS. Such large instances for the load testing tool are required to simulate 20 million publishing clients, occupying approximately 5 virtual machines, and 180 million subscriber clients distributed across the remaining 45 instances. As you may know, MQTT protocol realizes publish-subscribe messaging pattern, which supposes that the broker stores information about the subscriptions and, upon receiving published message, pushes it to the subscribers that have the corresponding subscription. The load generation process is described in machine-readable format in an XML file that is fed to the HiveMQ Swarm shortly. So let's take a look at this file. So here we have 2 client groups defined, 20 million publishers and 180 million subscribers. We also have 2 topic groups with 20 million subscriptions and 180 million subscriptions. This is to reach the 200 million subscriptions objective. Although only the 180 million subscriptions participate in the publishing flow. So below we define multiple stages of our experiment. The first stage is to connect the publishers to the broker deployment and subscribe them to the 20 million topics. So basically, the client can have a role of a publisher and a subscriber. So both roles can be possible. Then we connect the real subscribers, so 180 million subscribers, which subscribe to the topics that the publishers will go to. Then we wait a bit till all the synchronous processes kick in. Then we do a little warm-up stage with the publishers. And then we publish our load during some interval of time. After that, we wait a bit till asynchronous processes like cleanup take place, and then we do disconnects. Okay. So here is the line that will start the script. And yeah, basically I need to just push enter and the script has started. So it's distributed to the swarm instances and we see that the first stage started. Now we can look at the dashboard and Grafana where we see that the connections started to rise. We also have visualized the number of current subscriptions. There's also the number of incoming publishers and as well as outgoing publishers. On top of that, we also have publisher acknowledgements, also incoming and ongoing visualized. The cluster is at 40 nodes. We see the gradual rise in the system CPU utilization and in heap. So let's wait a bit till the clients are connected. Okay, so as you can see now, we have basically reached our goal of 200 million concurrent connections. This was distributed across roughly 15 minutes. And we also have reached 400 million subscriptions according to this graph. This is because we have 200 million subscriptions defined in a XML file, in the scenario file, and this number is multiplied by 2 because the subscriptions are replicated in the cluster. So once this stage is done, we need to wait a bit till some processes, some asynchronous processes are over in the cluster, and then we'll start the warm-up publishing, and then we'll proceed to the real publish stage, so to say. So currently we see that CPU utilization is at around 60 to 70%. Yeah. Heap utilization grew a bit. Well, this is basically because we have to keep information about all of these connections and subscriptions within the broker. Therefore, we have to utilize quite some heap. And now we see that our publishing started. So it will be a short stage of warm-up publishing. And we'll have to wait a bit for it to complete. So we'll see how publishing ramps up. It's already reaching 10 million. So this is still warm-up stage for us. So as you can see, the cluster so far managed to survive 10 million publishes per minute, and we will now gradually transit into the real publishing stage. To see 5 million connections per each node. So now, as you can see, we're in the publish stage. So the warm-up is over, and we increase the amount of publishes fired in the cluster. Goes up to 15 million per minute at the moment. Now up to 20 million. So we're closing to the 30 million publishes per minute fired at the cluster, and push through it. So I think we're really should already be at 30 million per minute roughly. Yeah, and continue publishing. As you saw with distributed publishing a bit over the clients, this starting times of publishing. So we finally reached 30 million messages fired at the cluster and passing through it. So now we will have to wait a bit again till these messages pass through the cluster. So we have to wait a tiny fragment of time, like if I'm not mistaken, 10 minutes or so, to see how the cluster handles this throughput of 30 million publishes per minute fired by 20 million publishing clients. So you know that internally the broker has to process these messages and find out which subscriptions these messages match to, and then it basically dispatches them to the corresponding queues. After that, the subscribers get the messages from the queue. So that's how the process works in a nutshell. And yeah, let's wait a bit more. So the publishing stage of the experiment is now over, and you can see that the cluster managed to handle 30 million publishes per it every minute for roughly 10 minutes. Right, so we have here all of the connections still in place. We have all of the subscriptions, and the publishing now stopped, and we basically will start disconnecting pretty soon. Right. So basically, once the publishers are delivered to the subscribers, we disconnect all of them. This process will take a bit of time due to the sheer amount of the connected clients, which are 200 million. Afterwards, the garbage collection will kick in at some point to free up the heap that we utilized. So basically, we already see that the amount of connections started to reduce. Okay. Basically, we are done with publishing and disconnecting our clients. So the connected clients count is back to 0. Basically, our experiment is over. And as you have seen, HiveMQ broker succeeded in handling the connections and the publishing load that we threw at it. So basically 200 million connections and 30 million messages per minute passing through the broker. The whole benchmark was quite heavy on the heap, as you can see on this graph here. This is because the state that we need to keep in the broker is amplified by the amount of connections that we had during the benchmark. However, if we refer to the production deployments, this memory consumption level is considered to be appropriate. Naturally, you also may notice this stage when we warmed up the cluster a bit. This has to do with how the scheduling algorithms of cloud providers work. So you have to convince them that you will need the resources that you actually applied for. Last but not least, I want to conclude this experiment with a tiny remark that, of course, it's not only about the number of connections. It's not only the number of connections that matters. The practical use cases demand high message throughput, which we also briefly touched in this benchmark. And some applications also require near real-time end-to-end latencies, since the broker is quite often used in the critical paths of the data infrastructure. At the same time, most applications have requirements to the durability of the data passing through the broker. So there is a whole range of requirements to the enterprise broker, with the supported number of connections being just the tip of the iceberg. So tell us more about the scale of your use cases and what considerations other than scale of connections you have. So thank you all for your attention. I hope that this benchmark entertained you, and looking forward to your questions. Thank you.
Awesome. Thanks to Vladimir for the demo. And I do see there were some concerns around the resolution of the screen share. So apologies for that. But what we have on our end is, as this recording is saving via Zoom, we have a high definition version. So when we share it with you after the webinar, we'll make sure that the resolution is taken care of. Apologies for the little hiccup that might have caused. But I hope the demo was useful. So looking through questions here, is there a specific one, Tamer, which you have in mind you want to address first? Because I made a note of a couple of, if you don't mind, I'll start with one and then I'll let you choose the next one, which you see is interesting. Is that okay?
Yeah,
Cool.
I see one in the Q&A window here. It's from Velmurkaran. And since for this demo, all the connections were made from devices from multiple locations in different networks. No, they were set up from the EC2 instances from the same network in AWS. So we took this decision because otherwise we would have tested more the network layer and the communication layer rather than the capability of our broker. It's not fully representing the real use case, but also will not have added more information about the resilience and the scale that our broker can reach.
Thank you, Tamer. And the one I noticed also was around, sort of any deviations from real world. I'm sure, when we are talking about this kind of 200 million scale, there's very few use cases in the real world, and our benchmark here has also, been created in a specific environment. Anything, Tamer, which we can share with our attendees today around real world recommendations versus any specific choices we made for our test? Can you speak to that, please?
Yeah. Well, one thing that we still talking about AWS and the hyperscaler environment that we used, we intentionally skipped the using load balancer here, and this is exactly the same reason as before. Depending on the types and the peculiarities of the setup and the way load balancer are implemented, they are introducing complexity and different side effects that are totally depending on their setup and their implementation. They will only add more effort in testing and configuration times without emphasizing the capability of the broker. So that's definitely a side condition that we decide not to include in this test, but they are still present in real world examples, so in real world use cases. So this is something that for production environment need to have a different attention and consideration. Another couple of things that we may want to highlight, the JVM heap of each broker instance was set to 85 gigabyte. And this was higher than the production environment recommendation that we have, which is 50% of RAM dedicated to the instance and 50% to the system. This was a control environment. We could account for a gradual ramp up, not big spikes. So we could save some resources and computing time and instances to be allocated to the test by taking this compromise of the heap size. In real world production, you have to accommodate and to allow some buffer for your instances and for your setup. So that's why we recommend 50% of RAM to be saved. Still on the more broker side and the configuration of our setup in the test, we intentionally disable throttling and overload protection. These are two features that are very important to protect the cluster from intentional malignant or unintentional spikes, and they are totally recommended for production. We disable it in order to have a quicker ramp up and a quicker subscribe and publish rate. Again, was a control environment. We had no malign intention toward our own setup, so it's the reason why we went to that road. If we would have had this feature turned on, the feature would have started throttling the incoming published messages. So with the current setup and the current standard, we'll have lowered the rate to about 450,000 messages per second, compared to the 500,000 of messages coming from the client to the broker side. So it's still not bad, definitely not bad, but it's will have not highlighted again the scale capability of the broker.
Yeah, and Tamer, one question which Victor has asked is, any wildcard topics? Did we apply any wildcard topics in this?
Not as I remember. No,
Yeah,
I
me
think
neither.
yeah, no. It's a different setup. It's definitely more memory and CPU consuming. But no, I don't think we had this information.
Sounds good. And by the way, I'm just reading through the chat messages. Some people are, the video share was leading some people to believe there's something to hide, but no. And by the way, if you go through the white paper we have a section there where if you want, you can take it for a run if you like, right? We have the schema there. So nothing to hide. So we welcome you to, check out the white paper. Tamer, what other question do you believe we should address?
For example, one thing that is highlighted in also in the white paper is the way we split the number of publisher and subscriber. We intentionally let 20 million clients to be the publisher and all the rest to be the subscriber to represent better the real case scenarios. If we would have gone for a 50-50 separation, this could have created misleading results. Some of which are, yeah, thank you, exactly. This is the image that I was thinking about. With having fewer publisher, you will ensure that the process messages are evenly distributed across all the broker instances. And this is important because, as I said, it's closer to real case scenario, where typically there are a small number of publishers that publish data to many subscribers. There are usually, for all our experience, for the vast majority of our customers, there are much more subscriber to publisher rate. Another thing that we may want to highlight that having this ratio 20 million to 180 millions will automatically trigger intra-cluster communication. So this means that we are putting even more stress on the cluster and on our broker, because when not all the time a publisher goes to the same consumer, to the same subscriber, this means that the messages need to travel across the broker, and this is much more closer to the real case scenario.
Sounds good. That makes sense. Thank you, Tamer. And our choice of QoS1, that's another interesting element here. I mean, of course, QoS1 is in a way best effort. QoS0 is best effort. QoS1 is deliver at least once. So we have QoS1 as the choice here. If anything around that specifically, we can share.
Yeah, again, is the most used quality of service level in the deployments that we see so far in between our customers. And as you said, is a good balance, because quality of service 0 are fires and forget kind of messages, and they reduce the load on the system. Again, this is a benchmark. We want to put our system at our cluster at a test. So it was good to see the messages and the network and the cluster be able to reach to these numbers, which are including, as I said, both the messages that are going to the cluster and then flying back to the client in the form of the pub acts. So yeah, that's totally against going toward representing a real use case scenario.
Sounds good, Tamer. Thank you. Any questions I might have missed? Jayashree, do you see anything on your end which we might have missed? Probably not, right?
Scouting through the chat section. Looks like we have covered
Okay, so in that case, just bear with me 1 second. I'm gonna bring my screen back up and let people know what we would be doing next. Just 1 more second here. So yeah, just as a next step, we would love to continue the conversation. And of course, if you already don't have a copy of the white paper, please follow this link here, which will be in the invitations we sent out to you or the follow-up we'll send to you. There is also a buyer's guide on MQTT we released pretty recently. So in case you want to refresh your MQTT knowledge and plus begin to now see MQTT as a viable option for you to scale. And as Vladimir mentioned in his concluding remarks in his demo, right? Scalability is just the tip of the iceberg. There is reliability quotient that you have to factor in, security, flexibility, and so many other elements. And this buyer's guide will give you a very good starting point to understand those elements and how you should evaluate all the options you have out there. So our mission, as I said, MQTT is what HiveMQ is supporting, is continuing to promote. And this buyer's guide is also where you'll get to see a lot of those details. So with that said, Jayashree, over to you. I know you have a couple of questions to ask our audience. How about you do that now?
So we have a quick poll. Let me launch the poll and run it for about a minute. I request you all to cast your votes. This will help us provide feedback about your use cases. Yeah.
Sounds good. So yeah, so if you could give us a sense of, go ahead, Jayashree.
Yeah, so I would also request you all to download the benchmark white paper. I have already given the link in the chat section. In case if you all have follow-up questions after the follow-up email or so, then you guys can use our contact us form. I will share the link as well here in a couple of minutes.
Sounds good. And here's our contact information, by the way, just in case anybody wants to reach out specifically to me, Tamer, or Vladimir. Okay. Did we get the responses, Jayashree?
Cool. Let me end the poll. Thank you so much, everyone, for participating.
Awesome. Thanks, everybody. Appreciate the time.
Thank you, everyone.
Thank you.
We already shared, we will be sharing the recording as well as the slide presentation in a follow-up email. Stay tuned with us. So see you all next time. Thanks, Gaurav. Thanks.
Bye.
Thanks, Tamer. See you all.
Bye-bye.
Bye-bye.